Alright class, parabolas day 1. There's a lot of stuff to write down, so please pause the video and write down the definition of a parabola, as well as these opens left or right or up and down. So these are the two formats that will do that for you. Alright, hopefully you paused, because now I'm going to slide down, you won't be able to see that top thing. Okay. So, I would say pause again and just write down all of these terms. And then I'm going to go on. So basically the vertex is very similar to the center of the other shapes for a parabola. We also have an A value, and if you notice up here, 4A is usually the number. So you can find A by looking at the number and dividing by 4. Focus is always inside the parabola. The directrix is a line that is perpendicular to the axis of symmetry and outside the parabola, and the axis of symmetry goes through the vertex. So let's do all these pieces with this parabola here. First thing is the vertex is at +2, +1 because of the opposite signs of the x and y. +2, +1. I also see that it's x squared, so it's opening either up or down. This is positive, so it's opening up, and that's only because it's x squared. Now, this number here is critical. Finding the A value is critical because it tells you how to move. So we know 12 is equal to 4A, which means A is equal to 3. That is the distance to the focus from the vertex. So if my vertex is at 2, 1, I'm going to go up 3, and my focus, I just found my focus, is at, so I'm going to write focus is at 2, 4. Now, to round out and graph your parabola, from the focus, if you move left and right, 2A, so 6 units, that defines the lattice rectum, and that's how you can graph this parabola. So there are these points on the parabola as well, so now we can graph it. So the parabola opens up. Again, this value is always an A value, and in this case A was 3. And then the value from the focus over to a point on the parabola at the lattice rectum is 2A. So it's a total of 4A across. So we have the vertex, we have the focus. The only thing we need are the axis of symmetry and directrix lines. So the directrix is the same distance away from the vertex as the focus. So if I go down 3, I put a point there. However, the directrix actually is a line, and it does not go through the parabola. So it's this horizontal line. So the directrix is at y equals -2. That's the directrix. The axis of symmetry goes through the parabola, through the focus and the vertex. So this would be x equals 2, because it goes through the value of x equals 2. So that's how you do a parabola. You really need to get that A value though. That's the critical point. Alright, let's try it again. First thing is I have to get in the correct form. Move that over. Notice how there's no number with the y or the x, so the vertex will be 0, 0. Notice how y squared comes first. This means that it's opening left or right, L or R. And since it's negative, it's opening left. Okay. The next step is to figure out the A value. So this number here, 20, is equal to 4A. That number is equal to 4A, which means our A value is 5 in this case. And we know it's opening left, so I'm going to put my vertex at 0, 0. It's opening left, which means the focus is 5 units to the left because the A value is 5. Remember, the LR points are going to help us define the parabola, and those will be 2A or 10 units in either direction, up and down, so that you can then define the parabola. This is a very wide parabola. Alright, so the focus is at -5, 0. The directrix goes the other way through 5, and it is, this time, the directrix is the vertical line. So we say x equals 5. And the axis of symmetry goes through all these points. That's a horizontal line. That is y equals 0. And that's it. We're done with the parabola. So you have to just identify the vertex, which way it opens, find that A value, and then start graphing and getting the rest of your information. Alright, down here we have an issue because it's not in standard form. It's in the general form, and we do know it's a parabola though because one of the values is squared. We're going to talk about that shortly. So write the equation. So we're going to do the same thing that we normally do with completing the square, except for we're moving anything that is not with the y to the other side. So I'm going to pull 3 out of both y things, so 18 divided by 3 is 6. And then over here, I'm moving the 30x and the 87. Half of 6 is 3, 3 squared is 9. But I really added 27 to this side, so I have to add 27 to this side. So negative 87 plus 27 gives me the negative 60. So this is really negative 60. Now, I'm going to factor this, y minus 3 quantity squared. I'm also going to factor this side. I can take a 30 out of both pieces, and I get x minus 2. So this is almost the general form. But remember, you can't have a number in front of the y for the general form for a parabola, so I'm going to divide both sides by 3, which really just gets rid of this and turns that into a 10. Which will then help us get our, all our other information. But we don't need that for this problem. I just wanted to do a complete the square for this one. So then let's try that with actually getting important information on the next problem. Okay? So here I have an x squared. So that means everything else has to go to the other side. So the y is going to be positive, then 18 is negative. Half of 8 is 4. 4 squared is 16, so I have to add 16. So I get x minus 4 quantity squared equals just a positive 1y. Negative 18 plus 6 is minus 2. Now, because there's nothing with this, you can think of factoring out a 1, which is important to get our a value. Vertex is the opposite of the x, opposite of the y, f4, 2. Put that dot down there. The a value, 4a is equal to this value, which is 1, which means a is only 1/4. By the way, this is an x squared with a positive value for a, so it's going to be opening up. So that means the focus is only 1/4 up from the vertex. So that means the focus is still at an x of 4, but now a y of 2.25. The directrix is 1/4 down, which is very tiny. It's hard to do that line. So if I go 1/4 down from 2, I have a directrix at y equals 1.75. And I have an axis of symmetry at x equals 4. The only thing I have to do is just kind of graph it. So remember, 2a, which would be 1/2, will get me this point and this point. So this is a very narrow parabola. Okay? Where the a value was 1/4. It's very tricky. And very small parabola movement. So. But there's that one. So now here's the last thing we're going to talk about today, which is identifying a conic without completing the square. So first of all, just so you know, general form for conics are ax squared plus cy squared plus dx plus ey plus f equals 0. Some people ask me, where's b? Well, technically there is actually a bxy term, but we're not dealing with that. And it doesn't really affect us at all. Well, for what we're doing. If it was there, it would, but we're not going to worry about it. So how do you know you have a circle? Well, if the x squared and y squared part are the same sign and the same value, so that means that a has to equal c and, well, so that's it. A has to equal c. Same number and sign, I'm going to say. Okay? That's how you know you have a circle. An ellipse is very similar to a circle, except for a is not the same as c. So a and c are different numbers, but the same sign. Okay, you need to have the same sign for a and c for an ellipse. Hyperbola, a and c can be the same or different. The key here is they are different signs. So I'm going to say a and c have different signs. They can be the same number or different numbers. Don't have to be the same. And I'll just say numbers don't matter. So some people thought it had to be different numbers. A parabola means that you only have one squared term. Which means either A equals 0 or C equals 0, based on this information I gave you. So why don't you guys pause the screen to write everything I just wrote down, in case you weren't following, or I go a little fast sometimes to make sure I get my 15 minutes in. And then we're just going to do these 4 quick problems. Without completing the square, we're going to identify which shape we have. And it's a very simple process once you practice it. All you have to do is look at the squared terms. Here's the first squared term. There is no other squared term. The one which means the one shape that only has one squared term is a parabola. We know for a fact this is a parabola because there's only one x squared term. I look at the x squared term and the y squared term. The numbers in front are both 1, and they're both the same sign. So this should be a circle. Same number and sign. This one, the y squared is negative, the x squared is positive. Automatically, there are different signs. It has to be a hyperbola. And finally, the x squared and y squared piece are different numbers but the same sign, which means now we have an ellipse. So that's how you do parabola, or that's how you figure out which conic you have without completing the square. It's a very simple process, and there will be one of those on your test. So anyway, that is it for tonight. I hope the audio is okay. I was not using my headset. I'm just kind of yelling at the computer. Hopefully you picked up all this. I'll see you next time.